So people are talking all about the oil and the oil restrictions on transport, as you mentioned, through the narrow strait, but also on oil production from the many companies that work with oil. But what people don't talk about so much is fertilizers, like the petrochemical industry, right, which produces plastics, fertilizers. It also produces pesticides, which are also very important for farming. So vast amounts of the global supply come from the Middle East.
Hello, and welcome to another edition of the Climate Emergency Forum. I'm Herb Simmons, author of A Climate Vocabulary of the Future, and I'll be your host today. Our program today is titled War, Fertilizer, and Food, Climate Resilient Agriculture. The headlines from the war with Iran have focused on oil, but there's a second crisis unfolding in the shadow of that one. It's largely invisible, and in some ways, it's more consequential. Consider this. Roughly 4 billion people, half the humans alive on this planet, eat food that could not have been easily grown under present systems without synthetic nitrogen fertilizer. And right now, up to one-third of the world's fertilizer supply is sitting behind a closed door. And that closed door is the 21-mile wide strait between Iran and Oman. There's no strategic reserve, there's no backup plan, and farmers across the northern hemisphere are in the middle, literally, are in the middle of the planting season. The consequences ripple outward to grain fields in Iowa, in the Punjab, in Ukraine, and in the Nile Delta. When enough farmers cannot get fertilizer, people go hungry. In the short run, the only real solution is to end the war. But over the next decade or two, a variety of promising alternatives to fossil fuel-based fertilizer are emerging, alternatives that could also make agriculture far more resilient in the face of a changing climate. And with that, we'll be discussing those issues today with our two regular panelists, Peter Carter, Dr. Peter Carter. Hello, Peter, from British Columbia. You're the founder of the Climate Emergency Institute, and Paul Beckwith from Ottawa, Canada. Paul, you are a climate system scientist with a popular YouTube program. Please stay until our program is wrapped up, when I will be presenting what we call the Climate Three, the three most important climate stories of the past week on the climate crisis, each presented in 1 minute or less. We invite you to like this program, to subscribe to our channel, and to visit our website at theclimateemergencyforum.org. If you find these programs of value, please consider making a donation so we can continue as one of the few, if only, programs on YouTube focused exclusively on the climate emergency. So, Paul, welcome, and tell us about the war in Iran, fertilizer, and why our viewers should be deeply concerned.
Thank you, Herb. So people are talking all about the oil and the oil restrictions on transport, as you mentioned, through the narrow strait, but also on oil production from the many companies that work with oil. But what people don't talk about so much is fertilizers, like the petrochemical industry, right, which produces plastics, fertilizers. It also produces pesticides, which are also very important for farming. So vast amounts of the global supply come from the Middle East. To give you an idea, a third to one half of the globally traded nitrogen fertilizer, especially urea, moves from the Gulf state producers through the Strait of Hormuz. To give you one example, Quafco is Qatari fertilizer company. They produce 14% of global urea, just the one company alone there. And we rely on synthetic fertilizers. They're very crucial for sustaining our global population. In fact, one of the most significant inventions in human history is the so-called bread from air Haber-Bosch process. So Haber came up with the concept in 1909, and then Bosch industrialized it from Haber's lab experiment. So basically, you create ammonia, and then ammonia is the feedstock into all these different fertilizers. You get the nitrogen from air. Now, the nitrogen molecule N2 is very, very strong bonds. So you need to have very, very high pressure and very, very high temperature, and you use iron filings as a catalyst to split the nitrogen molecule N2 into separate nitrogens. You use methane CH4 to basically get the hydrogens. You combine them to produce NH3. Now, this is used around the world for fertilizers. Before the process, we relied on manure and things like bird guano. But when we got the synthetic fertilizers, the yields went up many, many times, which has allowed the population of the world to grow to what we've seen now. Now, large fractions are coming from the Middle East. And the problem is whenever there's a lag from something happening and then the consequences, people turn the other way. We see this with climate change. People were saying that 5 or 10 years havoc's going to be wreaked on the planet from climate. Well, it's 5 or 10 years, so why worry about it today? Well, people are all worried about and talking about the oil going through the strait, but the farmers are going to be planting and they need this fertilizer. And if they don't have the fertilizer, then food yields will drop, food prices will go way, way up, and we'll have a global food shortage. The prices have already climbed in several weeks on many of these key fertilizers, and some countries are much more dependent on them than others. So, for example, India gets 40% of their urea from the Middle East through the Hormuz Strait, Australia 72%. And so the spot prices have risen 10 to 30% for these things in the last few weeks. It's a whole system, and the system seems to be very tightly coupled. It seems to be a lot more fragile than we think. We had a dry run with COVID, right, causing a lot of stresses. And we found out that the US, for example, in the West couldn't manufacture basic masks for people. China was the one that produced a lot of stuff that eventually came to the West. Then we had the Russia-Ukraine war putting restrictions on things, and now we have what's going on in the Middle East, and the system is proving to be extremely fragile.
Thanks, Paul. So, what you're saying basically is that we shouldn't be surprised in the next few weeks to see many of the crops that require or dependent upon synthetic nitrogen to start increasing in price, and that will show up in the supermarket and the bazaar all over the world. Is that fair to say?
Well, I think the time frame might be a little bit longer because there are global grain supplies that can carry us over a bit, and it takes time. If the soil is heavily fertilized one year, there'll be still some nutrients and so on in the soil. So if you use less fertilizer, your yields might not suffer the first year. I mentioned the pesticides. They'll just stop using as many pesticides. That includes insecticides, herbicides, and fungicides. So that's an even longer lag time to having negative consequences from not applying it. So that's the whole problem. There's a lag time, and people just do not pay attention to it because we're all in a very speeded up world, if you like, with our
Hey,
smartphone devices.
okay. Thank you, Paul. Peter, welcome, Peter. What's your perspective on this worldwide problem that is mostly behind the scenes right now, but is likely to sort of take center stage sometime soon?
Well, yeah, thank you, Paul, for explaining that so well. As Paul was talking, I recalled that over 30 years ago, I presented to the federal government on the issue of pesticides and agricultural chemicals and the adverse health effects, which have just continued and continued and continued. However, in this kind of situation, I think we should remember the result of Sri Lanka's change to organic agriculture in 1922. Sri Lanka banned pesticides and chemical nitrogen fertilizer. their agriculture and economy crashed, absolutely crashed. We have to sort of appreciate just how successful our chemical, nitrogen, potassium, which is mined here in Canada, and yes, pesticides and herbicides is. It's absolutely phenomenal the amount of food that it produces. I was amazed to read that the United States imports 25% of its natural gas. It's the biggest natural gas producer in the world. So it's importing natural gas as urea, as Paul explained. I mean, it's really crazy. I mean, the biggest natural gas producer in the world, and it does now already have a fertilizer crisis. The farmers in the United States are extremely worried. They're quite frantic when you read their letters to the editor, etc. So it's war, right? The problem comes down, as it does so often, to war. And war is intrinsically linked to fossil fuels, production of fossil fuels, manufacture, heavy industry, heavy armaments, on and on and on. I can share with you more direct repercussions of the ongoing wars with climate change, because they're a huge source of emissions. So the Iran war has been going on for 2 weeks. That apparently has led to the emissions of 5 million tons of carbon. And that amount is the same as the amount of the lowest 84 emitting countries combined in a year. So, as I keep on saying, I'm sorry, this is completely insane. We have the Ukraine war now going on for 4 years. Unbelievable. The estimate there is 300 million tons of carbon. Yes, we appear to be in an impossible situation. It's made more impossible because we don't have the leaders to make the interventions that are needed here. The leaders are sort of all at war with each other and crazy. And of course, we've got the Trump administration boosting everything. He's not a peacemaker, he's a war maker. That's pretty obvious now. So, yeah, I don't have solutions.
Thank you, Peter. I just want to clarify. I believe you said that the Sri Lanka was 1922. I think you meant 2022, just for the, though it may well have, that could have happened a century ago as well. But let me ask both of you. First, maybe just for my benefit, and I think for those of the viewers, can either one of you explain the sort of the enough of the process to indicate the role of urea versus natural gas? Because Peter, you said the United States is importing a massive amount of natural gas, and then you linked it to urea, and I wasn't clear about that.
Yeah, I think Paul explained that.
Urea, if you look at the chemical formula of urea, it's CO in brackets NH2 2. So ammonia NH3 is key for these fertilizers, the nitrogen-based fertilizers and then you have the phosphorus-based fertilizer, and then sulfur is also important in the process. But, getting back to the Haber-Bosch process, it was key because you take the nitrogen from air. Now, air is 78% nitrogen, right? About 21% oxygen with trace gases. But, the bulk of air is nitrogen. And nitrogen is a very stable molecule. The bond is very strong, triple bond, I believe. I have to go back to my high school chemistry. So this Haber in 1909 in the laboratory, he figured out he could take air, have his methane. I think he went up to 200 atmospheres of pressure and 450 degrees Celsius. And then he found, well, I still don't get enough nitrogen. So he used an heated iron filings catalyst. So the surface area would be large. And then he could split the nitrogen. So he'd have two ions. And then those nitrogens would combine with the CH4 with the hydrogens, producing the nitrogen urea, which then is the feedstock. And this was a huge advancement. There's no way global population would be more than about 4 billion without this process being invented. And that was just a lab experiment. And then along came the German chemical company BASF. Bosch was one of the employees, and within about a year, he figured out how to scale up the process to on industrial level, and the rest is history, you can say. So this is where they call it bread from air because the nitrogen is from the air. But this isn't a form that plants can use, right? So they're mostly soluble fertilizers. They can be applied on the field and they have basically instant response of the plants. And they can increase the yield of food production by incredible amounts. You'd have to check the actual numbers, but there's no way we would produce anywhere near as much food without this process. And it turns out that the natural gas, you need a big industrial plant, and these plants are located mostly in the Middle East for petrochemicals, not just for plastics and fertilizers, but also for pesticides, which are also vital in the agricultural industry. So it's all kind of connected. I call it a tightly coupled system. And when you chip away at the transport of these materials, and also at the production of these materials, you have a global situation developing, leading to food yield reductions, food shortages, price spikes. But
Um,
again, over a long period of time.
Thanks, Paul. Peter, any additional thoughts you have?
Yeah, I finished off in a very pessimistic way, saying that I have no solutions. So what I meant was there are no instant solutions, and we need immediate solutions. But of course, the only solution for the situation we're in is the same as climate change and the same as the wars, and that is a complete transformation of the international order in which we switch from a competitive, essentially war-based economy to an international cooperative economy of true mutual benefit. You know, decades ago, the idea of mutual benefit in trade and economics was talked about a lot. We need to go back to that. So that's really all I can say.
Well, that's a very ambitious goal, a very important one, and probably a very necessary one. Let's talk a little bit. In preparing for this program, I didn't know a whole lot about, I sort of vaguely knew who Haber and Bosch were, but thanks, Paul, for helping to explain that in some detail and how, reliant almost every one of us on the planet is in this, what is now a very old process. I mean, it's not something that's was invented yesterday. And as I see it there, or as I understand from taking a look, there are a number of different approaches to begin to address in the longer term, getting off of or modifying the sort of artificial fertilizer that we use. And one is to make the actual process greener through what's called green ammonia, blue ammonia, basically not using natural gas as much, but as using more renewable energy. And then a second approach is to change our farming to a more organic-based farming, which doesn't use nitrogen fertilizer or uses in a very, a small amount. And the third and the most revolutionary and perhaps the most promising is to genetically engineer our cereal plants so that they can fix nitrogen themselves the way that soybeans do and legumes do right now. So I wonder whether either of you would like to comment on any of those three approaches or any other sort of potential breakthroughs that we ought to be focusing on. So, I mean, war or not, I mean, the nitrogen production and use generates an enormous amount of greenhouse gases, including nitrous oxide and carbon dioxide and so forth. So we need to get away from them anyway, even if we lived in a totally peaceful society. So, Peter or Paul, any thoughts?
Yeah, you're so totally right, Herb. At the same time, we obviously have to make a big change real quickly here. Organic agriculture, in my view, is a huge success, but it's only a few percent of total world food production. We have permaculture, similarly, we have regenerative agriculture, but the lead times to make a transformation to these superior forms of food production and agriculture is many decades take a long, long time, even when if governments decide they're going to make this switch, but of course they're not because they're supporting the fossil fuel industry, they're supporting the pesticide industry. So, of course, governments are just getting in the way of everything. And I guess my final point has to be, yesterday or the day before yesterday, the World Meteorological Organization came out with the state of the climate. I mean, it was a very, very stunning, sobering report indeed. So we have to consider how much time we have in general. If we don't push our governments, right, force our governments to make the changes with respect to the climate, nothing else is going to work for us because we're not going to be able to make anything else work. So over and over again in all of this, our governments are in the way.
Well put. Paul, your thoughts?
Well, trying to replace fossil fuel feedstocks, I think that will, unless there's some scientific breakthrough that happens quickly, I don't think that's going to realistically happen on a short time scale. After the Haber-Bosch process came online and we could have better synthetic fertilizers and greatly increase crop yields, we kind of just got lazy, right? The world collectively thought, well, this works and we've got lots of fossil fuels. Stopping burning oil, right, is what we're pushing for because of the immediate greenhouse gas increase from oil burning, CO2. But a large chunk of the oil and the oil growth into the future, the demand is in the petrochemical industry. When you take oil and you put it into a distillation tower, so you basically heat it up, and different components of the oil burn off at different temperatures. So you can get ethylene, you can get different types of gases, which then act as feedstocks, like naphtha, for example, then acts as a feedstock to go into fertilizer production or pesticide production. So it's the cheapest way by far, and it works. And people don't like the big industrial plants in the West, so they just let them all be handled in the Middle East. And now we're seeing the problem. I mean, we've made ourselves very fragile to have such a high dependence on what's coming out of the Middle East, and that's going to take some time to change. And if the war suddenly ends, then people move on to other things. They don't necessarily build new petrochemical plants in other parts of the world. So it's just the way human nature is. If something's immediate in front of us, we react. But if there's a lag time of even a year or two, which would be what it is for food prices, and people don't react. So it's just part of human nature.
Thanks, Paul, and thanks, Peter. I just wanted to sort of wrap up this part of the discussion by indicating there are some things that you, the viewer, can do. I want to mention a couple of them. If you're in the United States, there is a bill right now that is called the Fertilizer Research Act that would significantly increase the amount of money going towards researching alternatives to what we have right now. It's, as I understand it, House Bill 6192 and Senate Bill 2808. So if you're in the US, write to your representatives. The Gates Foundation has done an extraordinary job since 2012 in basically funding research that could ultimately lead to, as I mentioned earlier, that cereal crops like corn and wheat and maize and rice and so forth could begin to fix nitrogen right out of the atmosphere themselves. So you'd basically bypass much of this. The research has been going on by a series of universities around the world, but we need more funding so that it can occur faster. So contact the Gates Foundation. So those are two very specific things we can do to try to hasten what will be an absolutely essential transformation. And as Peter pointed out, we don't have the time. We need to do this right away, but nobody can say that we don't have the resources and the scientific expertise. It's the political will that is lacking. If the world made this the equivalent of a Manhattan Project, both to get off of oil and to get off of mechanical and artificial fertilizers, we could do it from everything that I've read. So we need to be positive in the sense that the ability is there, the science is there, and we need your voice to make it happen. So thanks so much, Peter and Paul, for a discussion on something that I think is, not discussed quite enough. And sadly, it takes a war to, surface this problem and bring it out to us. And with that, let me turn to the climate three, the three big climate stories, or three of the many big climate stories over the past week that I'm going to just talk about in less than 1 minute each. And the first one is that the International Energy Agency, which tracks energy all over the world, have warned recently that the Iran war is, quote, the greatest global energy security threat in history. Politicians and markets, they say, are still underestimating the scale of the crisis, which is now larger than the twin shocks of the 1970s that triggered recessions and fuel rationing around the world. Even if the conflict ended today and the strait was reopened, it would be at least 6 months for much oil and gas to become operational, and much longer for some, as at least 40 major energy facilities have been severely damaged. So that's really something we should all be aware of in our own personal lives as we plan to navigate these turbulent times. The second of the climate three is the US, according to a new paper, has caused $10 trillion in global damages to the world over the past 3 decades with our emissions of greenhouse gases. And a quarter of the pain, quarter of the damage we've caused to ourselves. This is how lunatic this country is, and every country that isn't taking the steps to address climate change. China is responsible for $9 trillion, almost as large as the US. These damages, of course, will continue and only get worse. So if there's anybody that tells you that it doesn't pay to address climate change, show them numbers like this. It doesn't pay to not address climate change. And the third point, we've talked in one of our more recent programs about AI and data centers and its impact and some of the connections to climate change. There was actually a trial test recently. It involved thousands of flights between the United States and Europe, and they found that planes produce fewer contrails if they follow flight paths recommended by AI to reduce their global warming impact, because the streaks of condensation triggered by soot particles are thought to cause more warming than the carbon dioxide that the planes emit. And this research shows that AI can help navigate how the planes fly in order to minimize these consequences. So there's one positive aspect, and I'm sure we'll be hearing many, many more similar stories, positive and negative, about the pervasive impacts of AI. So with that, I want to thank Paul and Peter again. Thank you all for coming and watching today. And as always, we look forward to seeing you next week. Goodbye.